Hey, it's the sqrt, and we're back with part 2 of quirky and interesting math problems from the NYSMATYC Math competition. I hope you watched the first video in which we started going through some of these problems, but here are a few more because we ran out of time. Let's go to fall 2015, back up a little bit. This first one is a bit of a trick question. How many different pairs of primes can you add to get 2015?
And the answer? None. 2015 is odd, so the addends must be one odd and one even. 2, of course, is the only even number that is prime. So if 2 is the even number, then the odd one has to be 2013. But 2013 isn't prime. You can see easily that it's divisible by 3, and it's also divisible by 11 and by 61. So clearly there's just no way for 2 primes to sum to 2015, let alone multiple pairs of primes.
And then let's do problem 5 from the same exam. These geometry ones often stump me just because I ignore some silly detail. And this one I originally didn't remember that the corner of the one square was at the center of the other one, which you'll see becomes useful to remember. So there's always just something you need to realize, and it makes it a really, really simple problem, which is cool.
So here's our figure. We can extend both of these edges, and now we've divided the smaller square into 4 pieces. And with a little inspection, we can see that these 4 must be congruent. How do we know that? Well, the top and bottom of this square must be parallel, so these 2 angles are the same. And then likewise, we can use these right angles to deduce more congruent angles, and therefore shapes. So now the shaded area is 1/4 the area of the square, which is just 2 by 2, so 1/4 of 4 is 1.
Number 10, another geometry one. This one worked a little bit more straightforward for my brain. I don't know if you'll agree. I tend to like things where you can just draw triangles and evaluate them and it works.
So here we go. Here's our table in the corner of the room. Some point is 2 feet from one wall and 1 foot from the other. So let's draw the radius from that point to the center of the table, and let's also draw the line horizontal to that point and make it into a right angle triangle. Because the radius would have reached to the wall both horizontally and vertically, we know that the sides of this triangle are r-1 and r-2 respectively. So now we can just write out the Pythagorean theorem and solve for r. To multiply this out, combine like terms, and we get r equal to 1 foot or 5 feet. Then notice to have these values r-2, r-1, r must be at least 2 feet. So we take the 5 foot value, r equals 5 feet, and therefore the diameter equals 10 feet.
Let's do one more from this exam. This is number 16.
The pages in books and magazines are numbered such that you have the even number on the left and the odd number on the right. Obviously, if you were to rip out a page, you'd be removing 2 page numbers. The sum of numbers 1 through n is 1/2 n times n plus 1. Our problem, we've ripped out pages p and p plus 1, and we're left with a sum of 832. Note that the pages removed add up to 2p plus 1, which must be odd, for some integer p between 1 and n minus 1. We don't want to test all possible values for n, of course, so we want to eliminate which ones are definitely not happening. The lower bound, the value of n, is just that the total sum of pages has to already be greater than 832, elsewise how could you subtract and get that? Then n squared plus n must be greater than 1664. Now 40 is the square root of 1600. We don't really need to worry about this plus n over here, because if n were 40, then that's smaller than the 64 that we're cutting off from the other side. Now we also know that 1/2 n times n plus 1 has to be odd, because we already said that 2p plus 1 was odd. And that would mean that n cannot be divisible by 4, nor can n plus 1 be divisible by 4. But we'll see that that doesn't really matter as we get to a correct value before we really need that anyway. So let's try n equals 41. Both 41 and 42 are not divisible by 4, so that's good. And then we do 1/2 41 times 42, that gets us 861. This would mean, if you do little subtraction, that p would have to equal 14. But we know that p has to be odd because you tore the single page out. This is clearly not an acceptable answer. So we try 42. 1/2 42 times 43 gives us 903 for the original sum before tearing out a page. This would mean that we'd have p equal to 35, which is odd. This is perfect. And so the answer is 42. I love when that happens.
Okay, let's hop back forward in time to spring 2019. This is number 2 and a problem near and dear to my heart because it is about my namesake, the true square root of -1.
Hey, I'm square root of -1. Get it? I am square root of -1.
Right, so I is the square root of -1, and here we want to know the value of 1 minus I to the 2019 over 1 plus I to the 2020. Again, this is from the 2019 exam, that's why the numbers are themed. So we can pull out and multiply out both the top and bottom bases squared. This isn't the solution actually that they give in the official exam solutions, but this is how I like to do it. And simplifying I squared to just be -1, we can see that 1 minus I squared gives you -2I, and 1 plus I squared gives you 2I. So how many of these squared groupings can we pull out? Well, we can pull out to get you 2018, which is the largest even number below the exponents we have. And because -2I over 2I just equals -1, what we have is -1 to the 2018 over 2, which is 1009. And then we have 1 minus I over 2I, which we can simplify. 1009 is odd, so this whole thing's negative. Now let's just split that up into 2 separate fractions. And then on the left, we can turn -1 into I squared, and on the right, we can divide both top and bottom by I. Whoops, need to get rid of that I there. And now we can divide the left top and bottom by I, and we can recombine our fractions to get I plus 1 over 2, which is our answer.
Problem 11 of that exam collapses really nicely. Periodic things like this are fun to do. You just really have to redefine parameters and then you get it in a form that's just simple division or whatever.
Our function of x is sine 1 over x, and we want to find the number of intercepts between 0.0001 and 0.001 as values for x. Turns out the easier way to do this is to define variable y and have y equal to 1 over x, and therefore x equal to 1 over y. So now if we sub those in, we get f of 1 over y is just sine y. To get the range for y, then we just take the values for x and flip them. Obviously we have to switch the order because their inverses are going to be swapped in terms of which is larger. So that gives us a range from 1,000 to 10,000. Now that it's just sine y, it repeats when y changes by amount of 2 pi. So how many 2 pi's are there between 10,000 and 1,000? Well, that would be 4,500 over pi. So if we estimate pi as 3, that's approximately 1,500. This may seem like an invalid assumption, but we're just approximating anyway, and we don't have a calculator, so it's good enough. Then how many intercepts are there for each of those 1,500 cycles? You already knew this, but we draw it anyway. Sine crosses twice per cycle. That is 2 times 1,500 intercepts, which gives us 3,000 intercepts total.
And then this last one, problem 19, can be done 2 different ways.
Just based off of how you divide up that shaded area.
I think the easier way to do it is the square and the 2 triangles, so let's do that.
So here's our figure, and let's turn this shaded part into a square with 2 right-angled triangles attached. Now, to find the side of the square, notice that by parallel lines, this small triangle is similar to the big triangle on the left, including the shaded area and the area on top of it. So then we can take height over base equals, so 2 over 1 is equal to s over 1 minus s. And if we solve this, we get s equal to 2/3. So now the area of this shaded region is s squared for the square, and then 1/2 times 1 minus s times s. 1 minus s is the base of the triangle because we know that it's 1 where the median meets. So now we can plug in our value for s, and there's 2 triangles, sorry about that, and we get area equal to 2/3. Note that we could have gotten the same results doing it the other way. Area of a 1-1 triangle is just 1/2, and then you need some Pythagorean theorem and other ratios to figure out the rest. Let me know in the comments if you can explain how to solve it with this method.
I hope you enjoyed both of these videos and all of these math problems. They were really super fun. If you want to find more of them, you can always go to the NYSMATYC website and look up old exams. And if you're a community college student in upstate New York, it was a really fun time. You should definitely look into participating. I think there's a prize for the individual winner, you get like a subscription to journal or magazine of your choice. In any case, thanks for watching. Let me know in the comments if you'd like to see me do something else like this soon. Share this with all of your math loving friends, and I'll see you soon. Bye.